In this video, we're going to continue our exploration of solving quadratic equations, but our goal is going to be able to do so using square roots. So recall that when we work with equations of the form u squared equals some d, where d is a constant here, okay, this is some number, and we would say that u squared is just some algebraic expression, so algebraic expression. But if you can get some algebraic expression squared on one side and some constant on the other, recall that we can use square roots on both sides to get a solution to this equation. So we say this also works when one side of an equation is a perfect square trinomial and the other side is a constant. Essentially what I want to point out in this next series of videos is a method or a special factoring pattern that we would use here so that we could factor something that is a trinomial into something that is a perfect square binomial. Okay. So looking at what we have here, it says solve the equation by factoring and using square roots. Well, first things first, when you solve an equation by factoring, the first thing we usually do is set the thing equal to 0 because we intend to use what we refer to as the zero product property. That is to say, if two things multiply out to be 0, then one of them was 0 and we can set them each individual 0 and solve them. So looking at this, we say x squared plus 6x plus 9. I notice this is a trinomial where a is equal to 1. And I could ask, can we think of two values that when we multiply them we get a positive 9 but that also add up to be a positive 6? And in this case we get x plus 3 and x plus 3 equaling 0. So you notice we get the same answer twice, but really the thing I want to point out here is this. This is actually what we referred to as a perfect square trinomial. And we can tell that this is a perfect square trinomial, first of all, because what gives it away, actually I'm just going to hold off on this, what gives it away is that the first and last terms of our FOILed product here are perfect squares. This first thing is a perfect square of x, so that populates the first part of our two binomials. And 9 is a perfect square of 3, so that populates the rear. And then the 6 in the middle, what I can tell you is that middle term is always 2 times whatever x times 3 is here, which is 3x. 2 times 3 times x is 6x, but whatever this times this is here in each of these binomials, if we double that, we get this middle term. So essentially what I could say is that this original quantity, we could have factored it into x plus 3 squared equaling 0. And the nice thing about having an equation where one side of the equation is a perfect square trinomial and the other side is a constant is that now from here we could take the square root of both sides. And I get left with x plus 3 is equal to the square root of 0, which is 0, and then subtracting 3 from both parts of this equation basically leads us to the conclusion that x equals negative 3, and we got that answer twice. Okay, so I say notice that the left-hand side of the equation is a perfect square trinomial. That's important, but also that the right side has to equal a constant. If that's the case, again, we can use square roots to solve this. So what I want to do in these next two examples is essentially this. It says solve the following expressions for x using square roots. And so in each case, I'm going to go ahead and point this out, but the left side of the equation is a perfect square trinomial. We can tell this in the first one here because this is a perfect square of x, this is a perfect square of 5, and if I take 5 times x and double that, I get this middle term here. So when I say let's solve this using square roots, I'm really saying let's rewrite the left side as the square of a binomial here, and really literally x plus 5 squared equaling 16. So now that I can see that I have a squared expression on the left and a constant on the right, we'll take the square root of both sides and I get x plus 5 is equal to not just 4 but negative 4 also. And so we'll subtract 5 from both sides of this equation. And what we get here is that x is equal to negative 5 plus 4 and minus 4. So I do want to distinguish between these. Really I get two different answers here. I get negative 5 plus 4, which is negative 1. I also get negative 5 minus 4, which is negative 9. So we get two solutions to this quadratic equation. Now looking on the right, I also notice that the left side here is a perfect square trinomial. X squared is a perfect square of x. And I would say that 225, if you don't already know this, is a perfect square of 15. And I would say if I took x times 15, which is 15x, and doubled that, I get this middle term. So we could really write this as x plus 15 times x plus 15, or x plus 15 squared, equals 121. And again, we have this squared quantity on the left and a constant on the right. So we'll take the square root of both sides. We get x plus 15 on the left just by itself, and we get plus or minus, in this case, 11 on the right. So subtracting 15 from both sides of this, what we're going to end up with is this. We'd say x equals negative 15, x equals negative 15 plus or minus 11. Or in other words, we would say x equals negative 15 plus 11, which is negative 4, and negative 15 minus 11, which is negative 26. So that is how we're going to use perfect square trinomials to our advantage when we want to solve things using square roots. Cheers.